Alright, welcome to the Night Owl special. I'm a little bit hopped up on caffeine and I'm not tired yet, so we're going to do another repair tonight. We're going to do a sub-12. I've had a few people that ask me about this and want me to go over one, so that's what we're going to try and do. We'll see how far we get through it. We might have to continue this one in a part 2, but well, let's see what we got and see how far we get. Remember to like and subscribe too. I always forget to say that. But here we go. Alright, so first thing I've noticed is the fuse holder is just totally annihilated. And down in there it's just trashed, so that's going to have to be replaced. That's the first problem. And I was looking over the board a little bit just to kind of get an idea of what's going on with this. So this is a newer revision board. And the way you can identify that is Q5 is a T092 or TO92 transistor package. That designates that this is a later revision model. The earlier revisions had Q5 as a surface mount, and it is a known failure point. So I will not have to replace this one. Typically what I do is I'll cut off the surface mount component and I'll solder the legs of a through-hole component right onto the pads of the surface mount, and then I'll pot them in some epoxy to hold it in place. The Q5 should always be replaced with a T092. This amp is in fairly good shape. It's got some glue that needs to come off. It needs to be recapped. Other than that, it's not too bad. The inrush limiter, which is TH3, is not blown or burnt, at least that I can see, so we got to check the FETs. I did find a burn resistor here. This is R52, and if I look at my notes, R52 is part of the V plus and V minus supply, so that's the lower voltage supplies for the that feeds the regulators, and then it goes to plus or minus 15 volts. So something is wrong with that, which means we could have a dashboard problem, or we could have an op amp problem. So we'll have to get into that. So I guess this is interesting too. These wires are tape. Why is there tape on these wires? Let me guess. Somebody couldn't get the plugs out and they cut them. I know these wires are cut. To get these plugs out, all you got to do is just push this little tab in and they come right out. There's just a little locking tab right there. You can see it. They're not hard to get out. Even when they're installed backwards. I mean, they're a pain, but they're still not hard to get out. It comes right out. So let's see how bad our fused wires are cut. I'm hoping they're not cut, and this is just like some tape. Nope, they're cut. Actually, they're not cut, they're just damaged. Well, either way, we got to replace the fuse holder, so we will replace those wires. Alright, let's take the amp out and see what we have. So I normally leave the I generally leave the preamp board alone. I really don't do anything to it. Typically the caps that are on there are just smothered in glue. This one's not too bad. But there generally aren't any issues with this board, so I typically leave it alone. Sometimes I'll recap them. It depends on how bad they are. And you know, if there's any issues with them. But for the most part, it's usually always the power supplies that have problems. I have had a couple of amp boards that had some, various weird issues, but it's usually the power supply going bad that caused them. And we already got our favorite white silicone crap everywhere. The heat sinks on these are just smothered in this stuff. I don't understand why they use that much. And I hate this, but there's kind of no way around it. So known failure points on these amps are the PDC board, which is this guy here. On the later revisions of this amp, they did not put any glue on this board, so later revisions usually have other failures. Early revisions, it's almost always the PDC board because they put a ton of that yellow glue on there and it just nukes the board. When the board goes, it blows the FETs and takes out everything else around it. Now some of these boards have like a black rubberized type glue that I do not believe becomes conductive. Those I guess would be like a version 3. This one has the yellow glue on it, so this is not the latest and greatest, but it's newish. I don't know what serial number ranges or anything like that, have it, but hey, look at that, made in China. So you know I'm not lying when I tell you you're getting Chinese amps. And there we go. Look at all that thermal paste. Complete waste of thermal paste. And now I have to clean it up. And I probably don't have any cotton balls. Nope. The best way to get this stuff off is just take a cotton ball and it kind of sucks it right up. The next best way is a paper towel, preferably a dirty one. And you have to clean these off or you're going to get this crap all over your bench and all over everything you're working on, including your hands, and it's hard to get off. I hate this stuff. You can see all the battle scars on my mat from all this silicone crap. High quality amps don't use silicone goop. They use silicone thermal pads. Even so, this is still my favorite Klipsch amp. I think they have a very nice sound to them. They are almost identical, I believe, to the 300S that Parts Express sells. I like them. I think it's a good amp. I think they sound good. They function good when they don't die. So, alright, amp is out. Let me get my cheater cord. Alright. By the way, make sure your power is always off. If you got something like this, don't be stupid and zap yourself. Okay. So I am going to first just check to see if the power supply is functioning. If the power supply is functioning, that means that I can leave the FETs alone. Well, before we do that, let's just check and see if they're shorted. That's a pretty simple test. See if we have shorts. No shorts. One possible cold solder joint from the factory. Definitely a cold solder joint from the factory, but no shorts, so that's a good sign. And while we're at it, we'll check the gate drive resistors too, which I believe are... where are they? These are surface mount, so they're almost impossible to check on board. You got to go from the gate leads to the PDC board. That's really the only easy way to check them, and I don't remember what pins they are, so we're gonna guess and hope we get lucky. There we go, 100 ohms, because I don't remember what pins they are, but it should be 100 ohms. Either that or 220. Some of the versions have 220 ohms. There we go. 100 ohms. So gate drive resistors are good. FETs are good. That means the power supply will at least turn on. What happens after that, I don't know. Let's see. This resistor here is supposed to be 10 ohms. Let's see what he reads. The one that's nice and burnt. So that's reading 2.8 meg, so that ain't doing anything. It might even go up in flames when I power this thing on. So that's cool. Alright. Let's see what happens. This is how I test. I go right to the voltage regulators. So we'll go into voltage mode. We'll hook our current limited supply back up, and we will turn current limit... Oh, hold on. Helps if we're in voltage mode. Alright. We will turn our supply on and see what we get. And we have 2 volts, which is to be expected. We can check to see if the dashboard is working. And actually, no, we can't, because if we don't have plus minus 15, the dashboard won't get power. So we need to replace that 10 ohm resistor. And before we do that, we're going to just pull the caps out and recap it anyways, so we might as well just do that first. Pull the caps out. These boards definitely need to be drained. The primary, I think, has bleed off. A little spark. This one should get a pretty good spark, though. I saw it. I don't know if you saw it. There's 100 volts there, so just do it. Discharge the cap. We'll do the small ones first, just because I already have that tip in. There's a solder ball from the factory. I hope that comes out of there. There's a solder ball on one of the caps just sitting on the side of it. Let's see, who makes these? Junzel. High quality Junzel capacitors. Just what I want in my amplifier. Alright. I'm going to get the solder sucker heated up. These boards are extremely prone to damage from removing these parts. Actually, you know what? We'll do it the easy way tonight. Let's make it easier on ourselves. We'll just cut them out. Cut them out and minimize the risk of board damage. I think these are both the same. We'll do one at a time just so I don't have to look up what cap goes where. These are unpolar or bipolar. 4.7, 35 volts. I should have 2 of those. 4.7, 35. If you don't have 35s, you can use 50s. 50s are always my backup. But certain models do take the 50s, so keep that in mind. It's always good to start off with some fresh caps. And while we're at it, we'll fix this cold solder joint up here before I forget and don't do it. But even though these have some notorious design flaws, like I said, I still do like these amps. They're really good to use in DIY projects. I mean, these sub-12s are nice subs too. I mean, they're not like any of the flagship models, but I don't know, I like them. I don't have a room large enough to where I need, you know, a monster sub. I ran a RW10 in my little miniature theater for years, and that's because I got it at a garage sale for I think 20 bucks because it didn't work. But I have had one of these, and they are impressive little units. I don't know. They seem to put out a very clear signal and a decent amount of sound, and you'll be able to see the difference. Like if you watch my videos on the R115 series that I did some repairs on, the outputs on those have like a very jagged edge to the sine wave, and part of that's because of the way the power supply operates. It's a switching supply, and it's just poorly designed, so a lot of the noise from the supply gets to the outputs. That, and it's the way they design that amplifier. It's a Class D, but it uses like a really cheap Class D setup. Like if they would have used like a Texas Instruments or a I can't think of off the top of my head, but there's another chip manufacturer that makes a pretty nice Class D chip. I think it would have been a much higher quality design. They use I think it's Infineon. I'd have to look again what chip they use, but it's in my opinion junk. And the way that it operates, it allows a lot of distortion on the outputs. So we're a little bit close to one another. When they bend the leads over, sometimes you got to make sure that the leads aren't touching things you don't want them to touch. That's a common problem on some of these. Alright, these don't have a lot of caps on them. There's just these two for the audio path, and then these filtering caps for the different power supplies, and then two main caps. This is the main cap off the dial bridge. This is the filter cap for the output of the transformer. So I mean, it's pretty simple, straightforward. These are kind of easy to work on. This should be 100 and either 25 or 35 volts. This one is 35. Yeah, we'll do them one by one. One by one, so we don't make any mistakes. I made enough mistakes tonight already. On my previous video, I put the wrong resistors in a R115, wrong resistor in a R115. It still worked, but it was definitely the wrong value. Those resistors are meant for the outputs on a RT series, RT12. Only 500 ohms off, right? Not too big of a deal. Alright, 135 volts. You can see the difference between a Junzel and a Nichicon. A lot bigger, a lot better. Sometimes size does matter. But you know, if you don't have Nichicon caps or you can't get them, you know, any decent quality cap will work. Just don't buy your capacitors on Amazon or eBay. Buy them from an electronics distributor. Somebody that you know is going to get decent quality parts. And go on the bad caps forums and read about which caps you should be using. I mean, there's a ton of information on there about like which caps are bad, which caps are good. These guys, it's okay to bend them down and out of the way. And leave them that way. They get hot. They get real hot. This should be 47 and 50 volts. I'm going to go ahead and clip the rest of these out, and I'm just going to stack them in order that I took them out. So it goes 147, then this should be 100 at 35 volts. Actually, this one's 100 at 25 volts. Interesting. I have not seen them mixed. We're going to put all 35s in this one. 47. And this should be 100. And the last one should be 47. My dog is barking, so I need to pause and look at my security cameras really quick. Please bear with me. It's not normal for the dog to freak out this late at night. Well, I don't see anything going on outside. Although I did see a bright light. Okay, sorry about that. Just, you know, it's kind of late at night, and the dog started barking, so I had to check it out and see what it was. Well, here we go, back at it. So, we have our caps lined up in the order that we took them out. And now we will continue by, okay, that's the one we just put in. Removing the leads and continuing to replace these out. So dope them up, put a little solder on there. Then I heat up the through hole and pull the lead out. And it's the best way to do it without damaging the board. Should be one more here. One more at the top. Another cold solder joint. Alright, let's do the main caps there. So we got 135, next one's going to be a 47. Got 50 volts. Make sure these are all marked. Make sure you check your polarities. The round pad is your negative. And there is a little symbol on the board. It's really hard to see. You got to look way down in there, but you can see it. Make sure you get your polarities right. If you don't get the polarity right, pull the cap out and throw it away if you power the unit on. That cap is ruined. For the price of how cheap these are, if you power it up backwards and you catch your mistake after you're done, start over. Alright, next one will be 135. Oddly enough, the way that they made the through holes spaced on here, they don't fit any regular sized cap. I don't know why they did that. Most caps in certain sizes follow specific footprints, not these. These footprints are just wrong. Okay, so check our polarity, we're good. And these kind of rotate around and oscillate, so our next one is going to be a 47, 50 volts. They don't all face like the same direction or any specific direction. They're kind of all over the map. Alright, next one we'll do 135 volt. I find it interesting that one of these was 35 and the rest are 25. I've never seen a mix like that before. That's a new thing for me. I've seen them either all 25s or all 35s, never half and half. So again, check your, polarities, make sure you're good. Square pads get positives, round pads get negatives. Negatives are also marked. So just double check. Well, this one up here is going to be hard to snip off, like almost impossible. So what I'm going to do here is I'm going to blob each lead. I'm going to try and use the solder sucker to grab the lead and kind of straighten it out. It is risky to do it this way, but I can't really get in there with the snips to pull out. It's just too tight, so this is the better way to do it. Well, if I removed the large cap, then I wouldn't be able to get to it, but that requires me to change my tip, which I don't want to do right now. Actually, I gotta turn my Turn it off and let it cool down. And actually, I'm going to leave this 47 out too because there's a bunch of glue down there I want to get out. All that glue that's touching everything down there on that board's got to go. Alright, let's change tips. Make sure you're using water. It's probably not a good idea to dunk a blazing hot tip into a thing of alcohol. I don't think it's hot enough to ignite it, but I don't know. Still probably not a good idea. Alright, we're going to go to our large tip. It's going to get hot quickly. Don't leave your fingers on there. Cap off our water so we don't spill it. Although there is no easy way to get these off when they're glued. Big pliers. Big pliers is about the only way. And you might damage the through holes on them. I hope we don't, but you might. And the problem is you can't get, well, this one has an air gap, so, but you usually can't get any air to flow underneath the cap. So you have a really hard time getting the through hole to clear. We're going to put a lot of solder on these. The big one, not so much, but this one we are. And you can see, I mean, this thing is on there. So we're going to heat it up real good. Try as best we can to clear that hole. And the larger tip does kind of help with that. And you actually have to use some force. You got to kind of swirl the tip around there and, you know, put a little load on it. And now we can check the pins, and they seem to be somewhat free, so we should be okay. Those caps are they should have made the through holes a little bit bigger. These caps are extremely difficult to remove. Same with the big one. This one's not going to be that easy either because it's just got good glue on it. So we'll heat it up. It actually did come fairly clear. We might be in good shape here. Alright, that is all for the solder sucker. Now we got to get these things off. So there's two ways you can do it. Way number one is you can take, this is not good, you need something hard. Let me get my hammer here. Take something, you know, fairly rigid and hard. I have a wooden handled screwdriver I usually use, but it's in the other room, so karate chop them off. And you'll notice that it ripped the heat shrink stuff right off of there. Now you're trying to pull this off, forget about it. It ain't coming off. The base of that is just stuck there with glue. Well, this one, same thing, but we're going to hit it away from the transformer. And don't hit the transformer. You hit this and you're toast. Alright. Now we got to take the glue off. We can get rid of these other caps and throw these out. Straighten up our ones we bent. And for the glue, it's not terribly hard. Let's see if we can just scrape it off. Probably not. That ain't too bad. It's actually not bad at all. Not compared to sometimes. Like, this stuff is still fairly fresh. But if you can't scrape it off or you can't get to it, heat will do it. 120C on the hot air station will get that right off. And we'll do that over here too. We'll heat it up just to get a nice clean base for the cap to go back on. We'll get it away from these film caps. The film caps are fairly clean. Like, there's none of this glue has started turning brown yet. And don't get the film caps too hot. You don't want to damage them, but get the glue hot enough to where you can, get it out of there. If you scratch the board a little bit, that's okay. It ain't gonna hurt the board. So in between the caps, that's okay. You can leave that glue there. A little bit of residue underneath the big cap, that ain't gonna hurt nothing. This little blob right here on the pots, as long as it's not brown and like nasty and corroded, you can leave that. You can leave this, but it has to come off over here where it's touching the board. So we'll get in here with our heat. Heat and a dental pick. I will say that when the glue is like old and gnarly, it does come up a little easier. Like, this new stuff will fight you a little bit. But take your time. Just be patient. Don't, there are surface mount components in here. Don't rip them off. Just kind of work at it, heat it, and use your tools to pick it off. This is probably the most time-consuming part of these repairs, is getting most of the glue off the board. If you want to do it right, you got to remove the glue. And if somebody did a repair for you and they did not remove the glue, well, guess what? They didn't do it right. They half-assed a repair. This glue, no matter when or where it is, at some point will fail. It'll start turning that nasty color and become conductive. So if it's touching anything metal or it's touching any components, it's gotta go. So like all in here where it's touching these leads eventually, because these get hot. These 3 resistors do get a little warm. These are the current sense resistors that give feedback to the board here, the bash board. So this will all turn brown, and then it'll short out these 2 pins back here on the bash board right there. It'll short those pins out, and then it'll take out your bash board. And there are some surface mount components back there, so just be a little careful. I know it's a little hard to see in the shadow here, but I need to work this angle to get it out from underneath that bash board. And you know, if your temperature is right, it should come out in like chunks. If it's too hot, you're just gonna like tear it, and it's gonna get like real liquidy. You want it to come out. You want it to be almost like kind of dough. I don't know how to describe it, but like you want to be able to have where it still sticks together, but it's kind of flexible and pliable, so you can just get it all to come out together. And that way, any components that it's on or under, it comes out in one piece. Look around this little capacitor bead here. That's going to be a little more difficult, so we might have to get the tweezers to get that out. But you know, use your picks, use your tweezers, just take your time. You know, don't really worry about damaging the board too much. You're not gonna wreck the board. I mean, don't gouge it and deliberately try to ruin it, but just, you know, just take your time and just work this crap out of there. Get it out from underneath the pins. Don't leave, you know, don't just take it off the top of the pins. You gotta get it out from under them too. This one isn't as bad as I've seen. I've seen some that are much, much worse. But silicone would be the thing to use in here. So let's switch over to the tweezers too, just to make it interesting. Sorry, I know that meter's annoying. So what you can do is you grab it and then take your tweezers and start twisting them. And if it's hot enough, you'll pull it out and it'll wrap around the tweezers. And this stuff is still kind of fresh, so it's gonna fight us. If you keep the heat at 120 C, that really should be safe for almost any of the components on the board. You know, especially if it's powered off. It's just short-term heat. Film capacitors tend to be a little sensitive to high heat. 120 C sometimes it will damage a film cap, but these little ceramic beads and ceramic disc caps and the resistors are definitely not going to be damaged. Neither will any of the diodes or any of those parts. Almost there. We got a little bit left on this cap here. If we can't get it all off the leg of the cap, that's fine. Just make sure it's not touching the leg of the cap and the board. Let's flip that around so you can see in there. Alright. So here's our last little chunk. We got a little bit left underneath the leg of this ceramic cap here. So we'll clean that as best we can on both sides. And there's a little bit left on this guy here. Now it's not touching the board. I'm just trying to get it off just to get it off. You don't really have to. I'm going to hang up the hot air gun. I think we're good at this point. Alright. That's most of it. clean enough. That's gonna be fine. So all the glue is out anywhere where it's gonna cause us any problems. There's no glue touching the board anymore. Sometimes on these it will be dripping over the edge and touching the board. It has to come off if it's like that. Do not leave it on. Alright, now we can put our caps back in. We'll put our 47 in that we did put in earlier. Make sure to check your polarities. The board's going to be a little hot. You know, we're just blasting it with 120C for, you know, a few minutes, so just be aware of that. Alright, where are our big caps? We have a 160 volt 470. I hope I have one of those. Yes, I do. I have a few. So I have two different sizes. And some boards will take them, some won't. I got the, I think these are UPS. No, these are UPWs. These are great caps, but sometimes they won't fit. The leads are even bigger on these. So some boards will take these bigger ones, some won't. If they won't, you got to use a UVY. That one will fit in here. Make sure you check your polarity. Minus is towards the dashboard. And that is, you know, 160 volts. You can use a 200 volt. I have some 200 volts that are leaded if they'll fit. Some of these do use 200 volts. Some of them use the snap-in style. It depends on which revision of the board it is. And I am running low on these, so I'm going to have to order some more of these. I haven't worked on this many, or that many sub-10s and 12s lately. It's all been a lot of the newer stuff. Good solder joints. We're going to get it good and hot. Make sure the solder has a chance to actually get into the through hole. I might even hit these with the, let's do it just for the heck of it. We'll hit it with the big boy. Make sure it's really soldered in there. And our big cap, 560 at 200 volts. The SUB-12 uses a smaller cap. I think that's a 470. I should have some 560s. I think I have two different styles, depending on which amp they go in. These, who makes this one? TF. I don't know what TF is. I could think of something, but I won't say it. But we're gonna use, we'll use the GX. That should fit in there. Oh, actually, it might be too big. Let's see. Is it too big? Yeah, it's gonna hit the film cap and not sit in there nicely. We will use our smaller one. Check the polarity. Negative goes in the round pad where the minus sign is. Yeah, it snaps in there nicely. And it's not bumping into our film cap. That's why I keep a few different sizes of these. I have, let's see, I got some short and stubby ones, like little short and stubbies. This is a 220, but you know, different applications, different sizes work better for. As long as you're using a quality cap and it's rated for 105C, you're probably going to have pretty good results. And I'll use the solder sucker to solder these in. This makes sure that I got plenty of heat going in there, because there are some decent sized copper planes on here. Trim the leads. I have decided I am going to do another R115 SW video. I found a new way of mounting the resistors, and I kind of like it. It spaces them even farther off the board, especially since I'm using 5 watts that have a little bit shorter leads on them. So I'll make another video of doing one of those, and I'll show my updated method of mounting the resistors. I just want to get those things as far away from the capacitors as possible. Alright, I know I have a little solder blob on there, but that's going to get evaporated right now. So I know we have a good joint there. Coffee break. Alright, so now all that's left, well, actually, before we go any further, I'm going to get the screws off my desk. I'm going to get rid of these dirty caps, these used caps. And I'm going to clean off my mat. Get rid of all this junk and all these little leads. Not get rid of those. It's not beautiful, but it's functional. Alright, we have a burned out 10 ohm resistor. So this resistor, let me get original specs on this resistor. That resistor, R52, is 10 ohms, 6/10 of a watt, 1% tolerance. So I don't have a 6/10 of a watt, but I do have some 1 watts, and they are 1%. So I'm going to use one of these 1 watt and there's 2 different styles. Like, there's the big metal film ones, and then these are like flame proof. I don't know, they're made by Vishay Dale. They're good resistors. 10 ohm flame proofs. I'm going to use the little flame proof one. It'll fit better in that spot. So we got to go 3 in. And this is not typically a repair that I see often, or a failure that I see often. I have seen it before, but it's not typical on these. So there could be something else wrong with this that we don't know about yet. I have the large tip on here, so it's going to be a little difficult to try and flip this up, but we're going to try anyways. And we got it. We got one anyways. You got to be careful. These through holes and pads will tear right off. These boards have no mercy for any mistakes. So far, I consider it lucky. Bending that up and putting that heat on there doesn't ruin it. Let's see what this measures out of circuit, just for the heck of it. So this resistor is completely tight. It's reading the resistance through my fingers. If I just go to lead through the leads, toast. Nothing. Completely open. It basically acted like a fuse and is gone. So, we will put our new guy in there, and then we will power back up and see what we get. Maybe we'll get another smoke resistor, or maybe we'll get some output. I'm going to try and save any major damage by current limiting, but that doesn't always work. So we'll see what happens. If it does come up and all our power supplies are good, we might be able to test it out. These are always hard to get to sit in there nicely. Sometimes you got to just kind of grab one lead and straighten it out until you're happy with it. That looks alright. If you want to be OCD, you can do the little swirl with the higher powered iron. Since mine's still on, I'll do it. Gives you a nice little fillet. Is it required? No. Does it look good? Sure. Alright. That is pretty much it for this guy so far. Now we might have other issues, and I will show you how to find those issues if we do. I don't like how they smush these down on the board. I haven't quite figured out why they do that versus bending the leads and just raising them up, but I don't know. It's up to you whether or not you want to lift them and straighten the leads or just kind of leave them as is. Let's see if we get voltage now. And we should. We're still going to go current limited because this might have other issues. Let's see what happens. 25 volts, that's good. That's a good sign. And it'll climb to about 30. So that's good. So actually, I don't know why I powered it off. Let me get my leads. Alright, so that's check number 1. So that tells me that the power supply is working. I'm getting power to the regulators, which means I should have plus minus 15 volts. The next thing to check to see if the dashboard is working is the output from these two resistors. And with everything unhooked, you want about 5 volts between these two legs of these resistors down here. So let's hook it up and see what we get. And you got to be extremely careful when you're doing this. Don't short out the board. Just get to the leads and see what you got. And we got 6 negative. It's showing -6 because I was backwards on the leads. But if it's showing anything other than around 5 to 6 volts, if it's showing like a half a volt, or if these things are getting screaming hot, the dashboard is bad. In this case, you know, we got lucky. The glue wasn't on there real bad. It looked to be you know, not used heavily, so the dashboard is good. So we have all of our supplies working. We have our 5 volts, which is like your standby voltage, and everything seems to be in good shape. So we're going to pop this back in and see what we get out of it. Now, I'm not going to directly mount it to the plate. I'm going to sit it on there after I re-smear some of this excessive thermal paste back onto the area where it came from. And And I'll say this again and again and again, you don't need a ton of thermal paste. You need a light film. Like a transparent film is more than enough thermal paste. You don't need to slobber it on there, you know, a half an inch thick and expect that you're going to get better cooling, because you're not. It does not work that way. Let me say it again, it does not work that way. Alright, we will hold it on the plate with 2 screws. And hopefully we'll be in business. Remember, this cap still is charged, so be careful where you're grabbing. Interesting little booger of glue fell off. We're just going to lightly hold it on there with 2 screws just to do some testing. These screws may have to come back off when I fix the fuse. I'm probably not going to show that on this video because it's just replacing a fuse holder. I think if you're at this level where you're repairing amps, I don't think you need to see a fuse holder being replaced. But basically, I'll tell you what I do. I trim back all of this heat shrink tubing that's on here. On well, just on this one. On this one, I'm just gonna take a pair of cutters, large cutters. I'm gonna snip it, and then I'm gonna take a pair of pliers and just break this right off of the board or off of the plate. You know, it's covered in glue. I might have to put a cut with a razor blade through here after heating it up, just so it doesn't affect the input cable. But I'm just going to break this out. That's the easiest way to do it. That's really the only way to do it. Just bust it out. Alright. We need to be in quiet mode because my wife is in bed and it is 3:51 in the morning. I should be in bed. But let's see what we get out of this thing, and then I will call it a night. I think we did good. 2 amps. 2 amps tonight's pretty good. I will show you why I like these amps. Alright, let's make sure we're good. Nothing's shorted, nothing's touching, nothing's weird. Our power wires are good. We'll get our little scope in the video here. Hopefully we'll get output. If we don't get output, then we might have to do some troubleshooting. I think we're going to get output though. I'm optimistic because it's already kind of late and I think this thing just wants to work. So we're going to turn the low pass all the way up to 120, gain all the way down. My function generator is set to 46 Hertz. I'm going to go into, I'll plug in both. Oh, we got a loose one. Alright, I'm just going into LFE because the right side is loose on the plate. And that wire is already looking kind of sketch, so we're just going to go into LFE. But that's fine, we should still get an audio signal. Alright, current limit on. And I see a sine wave. It's a very little sine wave. Kind of looks like a pond with the wind blowing by. Let's give it some volume. That is a very... Oh, we're hitting current limiting. That is a very clean sine wave. Let's adjust the time a little bit. So you can see the difference between this amp and between like the R115 that I previously did tonight. Like the waveform is gorgeous. And sometimes if the bias is not adjusted correctly by those pots, you'll get like little notches in the waves, and you can eliminate those little notches by fine-tuning them pots. If you replace the outputs, you almost always have to adjust the bias again. There's no procedure that I know of how to do it. I just do it visually on a scope. So if you replace the outputs, that's something you got to look for, and you really got to zoom, way in on the wave. So you set your voltage low. You need a scope to do it. You can't do it without a scope. And you'll just look for a little disturbance in the sine wave, and then you just tune those pots until you get rid of that disturbance. It's really that easy. But this one looks really good. Let's see if we can go to 1 volt and really take a look at it. And you can see the whole wave. It's, even zoomed in, there's no ripples, there's no garbage. It's nice and clear. And this is going into a 4 ohm load. And a garbage scope. If I put it on the good scope, it would look even better. I would say that this is perfectly fine. So turn the volume down a little bit because we are at the edge of the current limit. Let's get this back on the screen. And we'll just check different frequencies to see what it looks like. So 50 hertz. We'll go up to 80, 90, 100, 120. It's at 40. You'll notice that you can see, so between like 120 and about, let's see where it starts to grow. So right about there. So at about 50 hertz, there's a small boost in gain. Let me just move this down. So if you look at the peak, I set the peak right there on that line, on this line here, and you can see as I turn that down. Let's see if I can do there. As I turn the frequency down, you can see we get a little bit of a boost. We're at 36 hertz right now, 27, and then it starts to, so under about 25 hertz it really starts to die off, but there is a nice little boost at some of the lower frequencies on these. And that's all due to the high and low pass filtering on this amp. So it's tuned specifically for the enclosure and box, but it works well. I've used car audio subs hooked up to these for testing, and they still sound pretty good. So this was a fairly simple one. We really didn't have to do a whole lot, but you can see we have a really good clean output. I don't need to hook it up to a speaker. I can just visually tell that this is fine. Like I said, I prefer these amps. I like these amps. I think the sub-10 and sub-12 amps are one of the better amps that Klipsch used in their subs. I mean, I like some of the RSW series things as well, but this is my favorite. This is the one I started working on. This is kind of what got me into the hobby of doing this, and I'm just kind of partial to these amps. I think they're somewhat well made for being a Chinese amp, if that makes sense. So I appreciate you following along. I apologize that this was a relatively easy repair. I'm glad it was, because it is kind of late. I have a few more of these on the shelves. I think some of them will be more interesting than this one, so just remember to like and subscribe, and catch me on the next one.